In this question, a scientist wants to predict the entropy change for the decomposition reaction of iron 2 oxide, FeO. Our first step is to fill in the gaps to balance the equation. I'm not going to show how to do that here. I'm going to assume you already know how to do that. If you need more practice, you can go back to the balancing equations unit to practice there. To balance this equation, we're going to need 2 FeO, 2 Fe, and 1 O2. Our goal is to figure out the entropy change of reaction. Let's head to our reference sheet to find an equation for that. Here's our entropy of reaction equation. The entropy of reaction is equal to the sum of the entropy of the products minus the sum of the entropy of the reactants. Remember, this symbol here means sum, or the total. So our first step is going to be finding the total entropy of the reactants and the total entropy of the products. We're given this table over here, which has the standard mole entropies for each compound included in our reaction. So for the reactants, we've got 2 sets of iron oxide, FeO. So 2 sets of iron oxide from the table here is 60.8. So 2 sets of 60.8 gets us 121.6 joules per Kelvin mole for our entropy of reactants. For the total entropy of the products, we've got 2 times iron and 1 times oxygen. So that's going to be 2 times iron, which has a standard mole entropy of 27.3, plus 1 times oxygen, which has a standard mole entropy of 205.1. So if we put that into our calculator, we get a total entropy of our products of 259.7 joules per Kelvin mole. So let's enter those numbers to check we got them right. Awesome. Okay, so our next step is finding our entropy change of reaction. So we're going to use our equation down here. So we're going to take our total entropy of our products, which was 259.7. We're going to subtract the total entropy of our reactants, which was 121.6, and that gets us an entropy change of reaction of 138.1 joules per Kelvin mole. So we can go ahead and fill that in here. We had 138.1 joules per Kelvin mole. Awesome. Now we also want to get that in kilojoules per Kelvin mole. So we're going to need to use a conversion. We're starting with 138.1 joules per Kelvin mole. And we're going to convert using 1 kilojoule is equal to 1,000 joules, because kilo means 1,000. So let's set up our dimensional analysis table. So we want to convert joules into kilojoules. So I'm going to put joules on the bottom, so that will cancel out, and kilojoules on the top. And then we know 1 kilojoule is equal to 1,000 joules. So the joules are going to cancel. Everything on the top will multiply, and we'll divide by everything on the bottom. And we're going to end up with 138.1 multiplied by 1 divided by 1,000. And our units will be kilojoules on the top and Kelvin mole on the bottom. So if we put that in our calculator, that gets us 0.1381 kilojoules per Kelvin mole. So again, we can go ahead and fill that in over here. Great. So finally we're asked, how does the disorder of the system change during this reaction? Well, our entropy change of reaction is positive, which means we have an increase in entropy. And entropy is a measure of disorder. So we have an increase in entropy. We also have an increase in disorder. So how does the disorder of the system change during this reaction? It increases. That makes sense based on our calculations, but also looking at what's happening on our reaction, we can see that we have no gas to start with, and we're producing 1 mole of gas in our reaction here. So the number of moles of gas is increasing. So based on our predictions from the concept skill, we're expecting the entropy to increase. So that makes sense. So in this skill, we've got 3 steps. Firstly, we're balancing our equation. Again, if you need more practice on that, go back to the balancing equations unit. Next, we're going to calculate the total entropy of our reactants and products by adding them up for each of our compounds in the reactants and products from the table. Then we're going to calculate our entropy change of reaction using our entropy change of reaction equation, so taking the total entropy of the products and subtracting the total entropy of the reactants. We're also going to need to convert that into kilojoules per Kelvin mole. Finally, if your enthalpy change of reaction is positive, that means we have an increase in entropy and an increase in disorder. If it's negative, we have a decrease in entropy and a decrease in disorder.